Hello and welcome. One of our subscribers asked me, what if there will be no data in the database? So then how the system should behave in that situation? Good question. Great point. So let's explore the situation when the system cannot find the answer in our database, and then we will need to go and search the web and bring the data back. This might be useful also for the enterprises when you want to create some FAQ for your end users, for example. Um, get the data from these places, from your documents, procedures, policies, but if it's not there, go to your website and maybe you can enable the search. Maybe you're updating something faster and it's appearing there, not there, many situations. So what I'll be showing to you now, it will be a small catalog of houses, prices, properties stored in a document, maybe later a DB, and then we'll be asking our AI agents to check and give an answer based on what can be discovered in that place. And if our agents will not be able to find the data, then they will go to web and fetch the data from there and provide an answer. And here you go. Okay, so how we are starting, what we are doing. As always, to suppress any warnings, we are doing this one and errors, loading our environmental variables, and yeah, you can ignore this one to easy debug. And for me, to be sure that everything is connected, I added some print um, print data so I can see that all my variables are connected. Then loading the dependencies, pipeline, routers, builders, generators, retrievers, web search. Here you go. Take a look on this. For the web search, we'll be using serper-dev, and this one serper-dev web search. And if you're using it for the first time, you might need a code or to connect to the API, a key to be more precise. So now, index documents to in-memory document store. This is our document variable, and we will be doing storing it in in-memory document store, initializing it here. I added just one document. Perhaps we will do a phase two now, and instead of this, we will also can create some database stored in DB. For the sake of example, why not? So this is our storage of docs. And now, yeah, we can run it. And let's see if everything is fine. By the way, it's great to run it from start. See, there is no errors. It's good. Let's run this one. It's fine. Let's run this one. No errors. Cool. And that gives an answer that we have only one document inside. Fantastic. Now, the prompt template. Take a look. It's again, you can see the form. It's a Ginger. And in Ginger, what is specified? Answer the following query. If you cannot find this answer within these documents, provide a no answer. Good. Having this in mind, let's get to and initiate the pipeline itself. In pipeline, as we will be using Retriever 25. Then what else? Yes, prompt build template track prompt template. So we will get this template here. And we call it prompt builder because later, actually on this step, we will need to connect those, and it's way easier to use slightly shorter naming like those things. Okay, so now it's connected. We connected the prompt builder documents, basically this one, and retriever documents. Basically, that's the our retriever here, and document store. Perfect. And here we go. And now we are connecting the uh, LLM. So we will be also using it to ask questions and to parse the results. And for LM, we're using OpenAI generator. Currently, it's model 4.0 is the latest. Yes, let's run it and see how it will go. Here we go. Good, 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 good. Yes, so here we can see what is expected and how they are connected based on the variables. And let's play with this. So I already made a predefined query and tried before. So for example, my query will be house and algebraic cost. And here might be a trick. Let's try it out together. Loading. Cool. Cool, 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 cool. So you see, it was able to discover the answer from our store. Nice. So we got an answer from our store. House net rebuild costs this amount of money. Yeah, 100,000. Okay, cool. Let me show you a trick here. Let's just, what is the price of the house in Retrieval? And take a look on the answer. Ah, it's still catched. Nice, unexpected. So what I learned today while playing with this, that quite often the OpenAI model was not able to understand the question, and it was providing me an. Not this time, not the previous time. It's still giving me the price of the house in Letterberg. Still good. So this is the power of using LLM in to understand what actually the user is trying to understand, and then get fetch the data from database. So this is exactly where LLMs can help. Still doesn't work well for me in the morning. I mean, in the morning, I mean later today. Okay, now it's working, and also you can see how many tokens we are using, this token, that token. So I spent already 87 token on these examples. Now let's see what will happen if we will ask a question that is not in our documents DB. Let's run it. Running. Okay, perfect. Oh, 76 token, crazy. But yeah, that's a lot of. So as you can see here, we got a no answer, and that is fantastically good because that's what we planned for earlier. We asked to have no answer, we got no answer. Great, great. Everything inspected. Now, it's time to create routes so we can do some routing here based on the conditions and take a look. We'll be having several conditions. If it's no answer, and we are doing in our case because there were situations when the models are returning it with a like that and so on. So we're adding the lower. And yes, if it's no answer, it goes to web search and finding information, giving it back to us. If there is an answer, if there is answer from our document, the system needs to reply us with an answer. Imagine this functionality. Just pause for a second and think on it. Which perspective, how many positive thing it's giving for enterprises. So you have this massive database and you can provide to your users information. If it's not there, you can say, hey, you cannot find it in that place, go to that place, go to that place. You can, and all of that is like a brain is controlled by the LM. So the input, the output is nice control. You can set some, you can pre-filter the data. So oof, so many things can be done. Love it. Anyway, let's check it on practice. So here, roads, yeah, and you see this time already places. So because you last time you were saying, oh, it's taking a lot of time when you were just typing and so on. So this time I typed and now we are reviewing all together with you. Hope that's better. Let me know if not, if you want to work in parallel. Same thing for me. Okay, so yes, now let's specify the prompt again using Ginger from the for the prompt web search. So answer given the documents, yes, answer retrieved from the web. And if you find that in the documents, for every document, search it. If you find it, great. Uh, your answer should indicate that your answer was generated from the website. It's important. Now, I think we're good to go. And the next step is to initialize our pipeline, Rack Web Search pipeline. So from here, these things you saw before, Retriever, our previous prompt builder, LLM, same, router, same, web search. Yes, we initialized our web search. That's what we'll be using once the answer will not be found, or then prompt build the prayed for web search. That's the one. Then prompt the web search. That's the one what we just specified. LLM for the web search. Yes, it's here. Um, Now, no, 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 no. A retriever, yes. So now we are connecting. We are connecting how it will go, builder to retriever, prompt to LLM, and then we are looking on replies. Based on replies, we will know which way to go to the web search query or from our document search. That is good. What we can do, let me run quickly this one to see if there are no errors. No, it's still good. And let's run exactly the same question, and see if there will be any changes. No, still good. So our system can find the answer in our database, so it's giving us the answer from there. But what if not? Take a look. What might be the cost of the house in the north of the Luxembourg? Previously, when there was no web search and we did this question, the answer was no answer. So hey, I don't have any answer. So sorry for that. Now we have web search. So if there is no answer in our database, we can say a go where it is north of the Luxembourg, and let's run it. Bam, bam, bam. Boom. That is amazing. Yes, and the system specified as we played LLM for web search. Great replies. Yes. Yes, you can see also here the links, what were used, but they are not in the output. They're just here in the prompt details or prompt details tokens. Here are the website's links from where the data were extracted. But the answer is here based on the retrieved documents. And look how it just sounds because it's coming from the LLM. It's retrieved and it's actually generated in a human readable way. Based on retrieved documents, the cost of the header part of Luxembourg can vary significantly depending on a specific location, type of property, for example, while the average price, blah, 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 blah. Amazing, amazing. So what we just did, super simple model, we're using the data from our database. If the data is not there in our database, it's using the web search. Um, what else? What else can be add? Think on it, give me hints, write a comments, how else we can extend this model. You can see how fast it is, how simple it is. You can transform it into a real application, and here you go. You can just work with that. That I think this is something what is quite applicable for many enterprises. Good. Thank you for being here, for watching this. If you will have any questions, just post under the video below or find me. See you soon. Thank you, everyone.